This is topic 8-3, interpreting changes in real-life situations. Our objective is I can interpret changes in real-life situations. So our central question is going to be, how can I interpret changes in real-life situations? We're going to begin with a Bell work problem. It's a review problem. We want to graph the equation for x plus 3y equals 12. And so for us to graph it, we must get it into y equals mx plus b form so we can figure out what our m is and what our b is. That means we're going to take this equation and solve it for y. So I drew my line down the equal sign and I wrote y equals with the equal on the line blank x plus blank. Now we want to fill in the blanks. Let's start by boxing in the positive 3y in the original equation because we want to isolate the y. So notice that the 12 is already on the opposite side of the equal sign, so it will not change. It's just going to drop down into our line that doesn't have the x with it. It's our constant. Next, we want to get the x to the other side. And so if I was solving for 3y, I would be subtracting 4x from both sides. So subtracting 4x from one side, I have to do it to the other side. I'm going to put the negative 4 in the blank to give me my negative 4x. So on the right side, the 4x is gone now. Sorry, the left side, the 4x is gone now. And now we need to get rid of the number that's in the box with the y. It is 3 times y, so to do the opposite of multiplication is division. That means I need to divide everything by 3, or the number that's in the box. So I will divide both of my terms by 3. Now we have to simplify our fractions. The negative 4/3 stays a negative 4/3, cannot be simplified, and then the 12 divided by 3 becomes a positive 4. So our slope is a negative 4/3, and our y-intercept is 4. When we graph, we begin at the y-intercept, or the ordered pair 0, 4, or the coordinate 0, 4. So that is a positive 4 on the y-axis. Then we're going to move that point, and the way we're moving it, it is a negative slope, and so that tells us it should be decreasing. So our top number tells us how far to go down, our bottom number tells us how far to go to the right. So from our y-intercept, our beginning point, we're going to go down 4, 1, 2, 3, 4, to the right 3, 1, 2, 3. We get a new point, down 4, 1, 2, 3, 4, to the right 3, 1, 2, 3. Here's a new point, and I'll continue this pattern until I fill up the graph. Draw my line, and sure enough, I get a decreasing line. So now's a chance to check your assignment from 8-2. You may pause after each page in order to check the answers. Here's the first problem. Our original equation is y equals 2x minus 4. Number 1 is y equals 4x plus 3. 2 is y equals 1x plus 2. And 3 is y equals 2x minus 9. Our problem number 4, the graphs have the same y-intercept. And problems 5-6. And now on to today's lesson. So we're going to do changes to real life situations. So rather than giving an equation or a graph, we're going to give a scenario. We have to come up with our equation and then make the changes. So just like the previous two topics, our first goal is going to be determining our original equation. Since we are dealing with real world scenarios, we refer back to our output is equal to how we begin plus or minus how it changes times our input. So we need to figure out what's the beginning and how it changes. Notice the beginning is our y-intercept and the change is our slope. The only difference is we're not graphing these because we're dealing with real world situations. So at Photoshop, you can have pictures developed for 55 cents per minute. There's a $1.25 processing fee, but you can develop as many pictures as you like. We're going to write the equation that could be used to determine the total cost C of P prints. And so we'll look and we see we have $2 amounts. One is 55 cents per print and the other is a $1.25 processing fee. Remember that our beginning amount doesn't change as what we start off initially. So when we go to this Photoshop, we're going to be charged $1.25 whether or not we get 5 prints processed or if we get 50 processed. We're still going to get that $1.25 processing fee. So we're going to start off owing $1.25. Next, we're trying to figure out what our change is. A key way to figure out what change is if you look at our equation, we see the change is always being multiplied by an input variable. So I want to look to see if there's anything in the paragraph that tells me that number is going to be multiplied by something. And sure enough, we look at the 55 cents, and this is 55 cents per print. The per always tells us, hey, that 55 is going to be multiplied by the number of prints, what comes afterwards. So since it is going to be multiplied by something, that tells us that 0.55 or the 55 cents is the change. So now I can come up with my equation. Our total cost is equal to, we start off with a beginning amount of $1.25. And to get a total cost, we know we're going to add then. And it's 55 cents per print. And this time, print represented by the letter P. Again, that per helps us figure out that the 55 is being multiplied by P. Now that we have an equation, then we can figure out the independent or dependent variable. In our vocabulary before, we saw that equals also means depends on. So if I read this equation, it tells me C depends on P, or my output depends on my input. C is also a function of, because our equal to also tells us means it's a function of. So C is a function of P. Once I know this information, then I know that our dependent depends on or is a function of the independent variable. Can't spell today. Now that we have our dependent and independent labeled, we can see our independent variable is the P or the number of prints. Now that we have our original equation, now we can see what changes are being made. So if the cost for developing the prints increases 20 cents per print and the processing fee is doubled, what's the new equation? So let's start off with, it increases 20 cents per print. Here's that per word again. That tells me I'm dealing with the change. So our original change was 55 cents. If it is increasing by 20 cents, increase means plus, so we're going to add 0.2 to it, and that means our new processing, our new print development cost is 75 cents per print. That's our new change. Okay, the processing fee is doubled. The processing fee was our original amount or our beginning amount. So our processing fee was originally $1.25, but now it's doubled. So we're going to multiply that by 2 and we'll get $2.50. So our beginning amount is $2.50. Now we'll rewrite our equation. The cost is equal to, our beginning amount is $2.50 plus it changes by 75 cents per print. Our second example, we have the bumper room is a bumper car amusement park. There is no entry fee into the park, but the bumper car rides are $1 per ride. We're going to write an equation for the cost C for riding B bumper cars. So our only dollar amount we have here is $1 per ride. Again, here's that word per, so that's telling us that it is going to be multiplied by something. That's going to be our change. I look back, a beginning amount is usually some kind of set fee. In this case, it says there is no entry fee, so our beginning amount is 0. So we'll write our equation for the cost. The cost is equal to, our beginning amount is 0, plus we have $1 per ride, and this time $1 per ride in the bumper. Writing the bumper is by the letter B. This can also be written because we have the 0, we don't need to show it. Our cost is $1 times how many bumper car rides we have. Again, with the equal sign, we know that C depends on B. We also know that C is a function of B, or this is our dependent, depends on, or is a function of our independent. This time it's asking what is the dependent variable. Our dependent variable is the C. It's the one that comes first in the equation. And remember, another way of remembering that is the D comes before I in alphabetically. So C is our cost. Now that we have our original equation, we can now deal with the changes. So what would be the new equation if it is a $5 entry fee and the cost per ride is tripled? So there is a $5 entry fee. That's our new beginning amount. And the cost of the ride, cost per ride, there's that per. That means we're dealing with the change, or the M. So M is tripled. So our original M was 1. It is tripled. That means we're going to multiply it by 3. So our new M is 3. Our new equation then is y equals. Our output was 5. I'm sorry. Instead of y equals, it's the cost is equal to, our beginning amount is $5 flat fee plus $3 times how many bumper card rides we have. So our summary that we can write is going to be very similar to our previous summaries. In order for us to interpret changes in the real life situations, the first thing we must do is we must come up with our original equation. So we're going to write the original equation. Finding our beginning amount and how it changes. We put the beginning as our B, the changes are M. Then the next thing we did is we made the changes to our beginning amount and the change amount, or the M. And then last, we write the new equation. I'm also putting here that the way we wrote the equation was our output is equal to how we begin. That was our B. Then plus or minus how it changes. That's our M times our input. So beginning and the change is what we're looking for. This concludes topic 8-3.